Hello everyone. Today we will be taking a look at forecasting options and possibilities for our company in regards of exchange rates for the US dollar and the British pound and how this can affect our company in the future. So a little briefing overview. What is the purpose? As a US company that has recently entered the European market, I believe this data is of our concern, as exchange rates are extremely important for any US-based business attempting to operate abroad, or as we are already operating abroad. It is important to see how these exchange rates will affect the sales, prices, and revenues for our products and services while abroad. It is also important, therefore, to be able to forecast these exchange rates in the future. They are currently unknown to us, but we can change that. Why? Well, if exchange rates fluctuate negatively, forecasting is a technique for estimating future aspects of our company. It is a method for translating past data or experience into estimates for the future. It is a tool which would be of great use to us, as it would truly help management in its attempts to cope with the uncertainties of the future. Here is our original raw, untouched data that we will be using. We have here the US dollar British pound exchange rates for the past 65 months, roughly about 5.4 years. So how can we take this data and find an efficient way to forecast future values so we can be prepared? Since this is actual historical and quantitative data we have obtained from our data sources, the best way to efficiently look at these methods of forecasting for this would be to look at time series models, especially trend and smoothing techniques. Today we will be looking at regression, seasonality, exponential smoothing, and 6-month moving average. The first one, regression forecast analysis, as we can see represented by the orange line on our graph on the screen, is a trend model that resulted in higher mean error, low tracking signal, low regression R-squared, and little to no correlation whatsoever in our data. The result? Not a very good predictor. So then we went ahead and moved on to seasonality forecast analysis, as we can see on the screen on the graph represented by the light yellow line. This trend model ended in a low mean error, high tracking signal, a low mean absolute deviation, but yet no set seasonality. The result, a better trend, better forecast, but not perfect. As we can see once again on the graph, some of the spots were over or under predicted. Since there appeared to be no set data trends in our company's raw data, I moved on to smoothing techniques in order to see if there is a better forecaster for our data. Smoothing methods are appropriate when a time series displays no significant effect of trend or seasonal components, as we previously saw. So here we have a smoothing method which resulted in a higher mean error and a higher tracking signal with values much higher than the 4 and -4 range, as we can see once again on the graph on the screen represented by the light blue line. We can see the result then, an average predictor, not the best forecast. So then we went ahead and moved on to 6-month moving average data smoothing. The moving averages method is the most widely used smoothing technique, and in this method the forecast is the average of the last X number of observations, where X is the most suitable number. In this smoothing method, represented by the light green light on the graph on the screen, resulted in the lowest mean error, the highest forecast similarity, and the smallest mean absolute deviation. The result? A good predictor, but once again, not perfect. Why? Due to that 6-month data limit. So then, let's move on to our failures and successes. As we discussed, we can see that regression and exponential smoothing did not result in the best forecast, resulting in failures. However, we have our seasonality and our 6-month moving average, which gave us much better predictors and much better forecasts. Therefore, those resulted in successes. More specifically, we will be focused on the 6-month moving average. As we previously mentioned, we can see that the 6-month moving average is a good predictor and can provide us with the forecast values we need. In order to prove that to you, I have here a table that has those 6-month moving average predicted values for the months to come. Even though it limits us through its 6-month moving average, we can see that since it is still a long period of time and data does not appear to fluctuate too drastically throughout time, this could potentially work for our company. And this is why I believe this could be the best technique we should acquire and use in predicting future exchange rates for our business abroad. This is also why I want to show these forecast values that we can already acquire on the screen for you. So then, a briefing conclusion. What is the solution? Time series analysis. Forecast, forecast, forecast. This way, we can expect and predict beforehand and save our company money, making sure we are prepared for anything to come.